Dear students, now we are going to see the subject of linear integrated circuit. The subject code is EC3451. Under that, the topic is dual slope ADC. On completion of this dual slope ADC, students will be able to explain the dual slope analog to digital converters. In dual slope ADC consists of high input impedance buffer A1 and a precision integrator A2 and a voltage comparator. VA is the analog input is integrated into a fixed duration of 2 power n clock pulse period until the integrator output becomes 0. The internal reference voltage VR of opposite polarity is integrated depending on the value of analog input VA averaged over the integration period. The number of clock required to return the integrator to 0 value as start command is received. Switch SW1 connect the ground and switch SW2 is closed. Till the threshold of comparator is achieved, the integrated comparator loop appears across the capacitor CAZ and which provide automatic compensation of input offset voltage to amplifiers. When switch SW2 open, CAZ acts as a memory element to hold the voltage which is required to keep the offset null. At another instant of time, when start command is received, a switch SW2 open and switch SW1 is connected to the analog input VA and enable the counter to start from 0. The circuit uses n-stage ripple counter and hence after counting 2 power n pulses, it resets to 0. So the figure represents the dual slope ADC with the two switches SW1 and SW2 and the 3 op-amp. First op-amp acts as a comparator and the last one is also act as a voltage comparator. So control logic that provide the control signal for A1 and A3 comparator. So finally we are having end stage counter. The end stage counter only provide the output of digital signal. So dual slope ADC output waveform is shown in figure. Auto 0 is obtained up to the time period T1 from T0. Then after T1, the negative ramp is generated up to the time period T2. So negative peak is obtained at time T2. Then a rising edge is obtained from T2 to T3. And after T3, again the voltage is set to auto 0. After resetting counter to 0, switch SW1 is connected to minus VR. The output voltage VD will have a positive slope as long as V0 is negative and clock pulse gets counted. At time T3, it receives end of conversion command and counter gets stopped. So T1 is equal to T2 minus small t1, that is 2 power n count divided by clock rate. T3 minus T2 equal to digital count n, capital N divided by clock rate. The change in output del V0 equal to minus 1 by RC into V of del T. Then V1 equal to minus 1 by RC VA into T2 minus T1. Then V1 is equal to minus 1 by RC VA is replaced by minus VR T2 minus T3. VA into T2 minus T1 equal to VR into T3 minus T2. Put T2 minus T1 equal to 2 power n and T3 minus T2 equal to capital N. So VA into 2 power n is equal to VR into n. So VA is equal to VR into capital N divided by 2 power n. The integrator output ramp down to voltage V and get back to 0. Therefore, the charge voltage is equal to discharge voltage and VIT1 by R1C1 equal to VRT2 by R1C1. VIT1 equal to VRT2. Therefore, T2 is equal to VI T1 divided by VR. T2 is directly proportional to VI since VR and T1 are constant. At time T is equal to 0, analog switch is connected to the analog input voltage VI and the analog input integration begins. The output voltage of integrator can be written as V0 equal to minus 1 by R1 CA1 integral 0 to T VI dt, that is equal to minus VI T divided by R1 C1. Where R1 C1 is the integrated time constant VA is assumed constant over the integration time period. Observation made: as the reference voltage and N are constant, VA is proportional to capital N, that is the counter reading, and is independent of resistance, capacitance, and the time. The DC integrate for a fixed time of input. It has an excellent noise rejection ratio of AC signal. Disadvantages: it has a large conversion time. It shows accurate measurement of slowly varying signal. Applications: it forms a digital panel meter and multimeter, etc. They are available in monolithic form as both in microprocessor compatible and in display oriented version. Possible quiz question: the advantage of using dual slope ADC in digital voltmeter is the accuracy is very high. Thank you.